Hey everybody, Mr. Bress here. With sort of Thanksgiving kind of coming up on the horizon, I thought maybe I would try to give a Thanksgiving feast or kind of a potluck analogy to DNA, RNA, and proteins. So I just kind of thought this up. So I'm not sure it's going to be a perfect analogy, but let's give it a try and see if maybe this helps put some of the things in context for you. And if you already have it there, maybe it's just a silly way that you can try to explain it to someone else down the road. So let's give this a try here and see how it works. I'm going to pop over to the iPad here because I did a little drawing in Notability. And I am not an artist. I got a C minus in art in seventh grade. So you guys can also maybe laugh at my artistic ability. Here it is. Okay. So in a feast, what are we trying to do? In a feast or a potluck, we are trying to make food. That is the important thing in a feast, right? You need to bring a dish. If a potluck is a thing where everyone brings a dish, right? And you kind of share all of the dishes. So the thing you want to create is the food, the item. And here I have some sort of cookie biscuit thing. Here I have some stuffing, and I didn't even try to make a tamale down here. But the food is the important thing. The analogy to that is in humans. What you see, what makes us work, what makes us fight infections, what gives us our muscles, what does everything about us is protein. We are proteins. We are walking proteins. So that is proteins, all the different proteins, 100,000 proteins in our body are like the various different dishes, food items that we're making. So the food item and protein are the same thing. We're trying to make, in our bodies, we're trying to make protein. In this analogy, we're trying to make some dish to bring to the potluck. And so if we go all the way back to where we're trying to make our food from, how do we know what to make? How do we know how to make the food item? How do I know how to make a cookie or stuffing? Well, now it's digital, but back in the day, maybe some of you have seen in grandma's kitchen or whatever, that there's a recipe book. And this recipe book has all of the recipes for all of the possible food items that we can make. And on each page is a different recipe. There might be a page that has a recipe for cookies. There might be another page that has a recipe for stuffing, another page that has the recipe for tamales. So you now have your individual recipe out of this whole book. You know, this is one page out of 1,000 pages in this book. But that's we can't eat that. You don't eat the rest. I'm not going to just bring the recipe. Hey, here's my recipe for cookies. I'm going to bring that to the potluck. People are like, what? I can't do anything with this. This isn't anything. So what I need to do is I need to read this recipe, move around, and cook it. I need to be the chef. There needs to be a chef. But just me, I can't make this. What do I need? I need ingredients, right? Now, me, the chef, I'm not a great chef, so maybe you are a better option. You, the chef, plus the ingredients, can read the instructions from this recipe and produce the food item, the important thing, the protein in the end. And you might be able to see where I'm going with this. So the analogy comes out like this. This recipe book, oops, oh, that was a little too much. Let's see if I can make this. Let's see if I can get this right. Oh, darn it. Maybe it's easier if I just write it. And you might have seen what I was doing there. Whoa, that's pretty thick, huh? Let's try this. The recipe book is the DNA, right? The recipe book is the DNA. That is where all of the information is stored for all of the recipes. And one of those thousands of recipes in this book, That is our mRNA. It is the message, right, from this book that we take out of this book and gives us the instructions on how to make that one particular food item. And us, the chef here, we're the thing that kind of moves around and grabs food items and puts it together and does all of the work to put together our dish, our protein. And so we are the ribosome. The chef is the ribosome, right? And we need ingredients. We need various ingredients to put them together to make our dish. And the ingredients in our bodies are the amino acids. So, a funny thing about us in our bodies is we only have 20 amino acids to choose from. So, we need to make all of the different proteins or all of the different food items we're going to make from just 20 amino acids. Now, think about that. I actually had another class think about it, and we tried to come up with what would be the 20 most staple ingredients where you could make as many food items as possible. You could think about that. What would be the 20 items you would put in your list? And I'll just show you because it's fun that we made this list down here. So remember, there's only 20 different amino acids that can get made. We thought there'd be eggs, butter, milk, flour, salt, water, cheese, sugar, ground beef because it's versatile. I'm trying to eat less meat, but and then someone put pineapples. I'm not sure. That's a pretty specialty. That's like the proline or the tryptophan of ingredients right there. Bananas, I think, are pretty versatile. Potatoes, onion, tomato, lettuce, peas. That's like I don't know which one that would be. Rice, beans, pepper, and corn. So remember, there's only 20 amino acids, and so 20 ingredients. Okay, that was just an aside. But the ingredients are the amino acids. And when you put the amino acids together in different combinations, you can make different food items or different proteins. These are our proteins here. Okay? And so that's pretty simple. The recipe book, the whole book is DNA. One page of that book, one recipe out of that book is mRNA. You need ingredients and a chef kind of read the instructions and put it all together, and they make the protein at the end. It's really pretty simple. And in this class, the central dogma, what's called the central dogma, and Mr. Austin's talked about this a couple times, of molecular biology is really simple. It's getting from DNA, will this work? Get to DNA to RNA to proteins. So get from your recipe book to an individual recipe to making the food item at the end. It's really simple. And this process of getting from DNA to RNA, we just give that a name called transcription. Transcription. To transcribe is just to rewrite something. So basically, we just looked up in our recipe book and we copied down, we rewrote the recipe for cookies, right? And the more difficult task is to get from that recipe that's just a piece of paper with words on it, and we need to change that whole language into that food item. And to change a language from one thing to another, to change it from just simply on a piece of paper to something we can eat, it's a little bit more complicated. We need to translate that. Translation. So if you understand this, you basically understand everything that's happening in our bodies, right? DNA goes to RNA, goes to protein. A recipe book goes to an individual recipe for a food item, to the food item at the end. Now, if you wanted to extend this analogy, and I'm not sure I'm ready to do that just yet, is you could imagine that this is grandma's recipe book right here, right? This is grandma's recipe book. And let's say you're getting married and you're starting your own family. Well, grandma could bake you some cookies. Grandma can make some stuffing for you and give it to you for your family, but that's only going to get you so far. right? It's going to get used up after a little while. And that's actually a pretty good analogy to the body. So if we're making a whole new family, a whole new cell, we need to rewrite the entire recipe book. So when we rewrite this recipe book, we need to copy that whole book every time someone in our family gets married and moves on and starts their own family. We need to rewrite that book. We need to replicate that book. And that's just called replication. But it's not a simple process, right? Can you imagine rewriting this entire recipe book every time? And that's what our cells have to do every time we make a new cell in our body, because cells in our body, we get bigger, right? We get bigger, we make new cells. Our cells get exposed to the environment and they die, and we need to make new ones. And every time that happens, we need to make a whole new recipe book, and that's replication. So I don't know if this analogy was helpful at all. You at least you get to laugh at my drawings here, and I hope you're doing well. I hope some of this makes some sense to you, and I wish you a great weekend and good luck in the future. All right.